Um, Number 18, still using linearization. So, approximate the root by using linearization centered at an appropriate nearby number. Um, so we're going to approximate the square root of 47. We're going to use the function f of x is equal to the square root of x, and we're going to center the approximation at a equals 49, since 49 is the square root of 49 is 7. So it's something close to 47, and it's a perfect root. So let's find the y value, f of 49. That's going to be equal to 7, and then f prime of x, the derivatives, if we're finding the slope, is 1 over 2 square root of x, and in this case, we'll do f of 49. That's going to be equal to 1 over 14. So my linearization is going to be the slope, sorry, that's f prime, 1 over 14, x minus 49, the x value, and then plus the y value 7. And we're trying to approximate 47. So that's equal to 1 over 14. That's going to be negative 2 plus 7. So we're going to get negative 2 over 14 plus 7, which is equal to 7 minus 1/7. And so here's our approximation for the square root of 47. Okay. It's funny. If we plug that into a calculator, which kind of defeats the purpose of what we just did, but whatever. That's what the key has. The key has the answer in decimal format. So yeah, whatever. It's going to be equal to 6.857. Sure. Okay. Um, find dy given this right here. So I know dy dx would be equal to 4x plus 6. So dy would be equal to 4x plus 6 times by dx. And there you go. There's differential y. Okay, so the function f changes values when x changes from a to a plus delta x. Find the true change and the estimated change. So let's find the true change first. So delta f is going to be equal to f of a plus delta x. So that looks like it's going to be 6.06. So 6.06 minus 6.06 squared. So let's go ahead and oh wait, 1 second. We forgot the second part, which would be minus f of 6. So that would be minus 6 minus 6 squared. So 6.06. I'm doing this in a calculator, by the way. Minus 6.06 squared. And then I'm going to subtract 6 minus 36. And I'm going to get negative 0.6636. So this is the true change. And for the estimated change, we're going to do f prime of 6 times by delta x, which would be 0.06. So let's find f prime of x. That's going to be equal to 1 minus 2x. And f prime of 6 is going to be equal to 1 minus 12. And we're going to multiply that. So f prime of 6 is going to be equal to negative 11. So our f prime of 6 times by 0.06 is going to be equal to negative 11 times by 0.06, which is equal to negative 0.66. So here's the estimated change, here's the actual change. So again, just so you guys are aware, this is dy, this is delta y. Remember that they're not going to be the same, unlike dx and delta x, those will be equivalent. So, okay, the radius of a right circular cylinder is increasing. So, got the cylinder, right circular cylinder just means it's upright, and it's got a radius of 3, and the height is decreasing. So this is a related rates problem. So let's see, what do we want to use here? So volume of cylinder is changing. So we're trying to find the rate of the volume, and we're relating volume to rate. So we have the rate. The right cylinder. The radius is rate, and the height's rate. So we want to relate R, H, and volume. So volume of a cylinder is equal to pi r squared times by height. And, okay, nothing's constant here either, because the height is changing, the radius is changing, the volume's changing, so none of these variables are constant. So, that being said, and we have all the rates of each of r and h, we'll just take the derivative. So dv dt, since we're taking the derivative with respect to time, is equal to, we have to use a product rule, so we'll do the first, times by the derivative of h, which would be dh dt, plus the derivative of the first, which would be 2 pi r dr dt, so the first times the derivative of the second plus the derivative of the first times by the second. So we're trying to find dv dt, that's what we're looking for, and that's equal to pi, and then when the radius is 19, so 19 squared times by the rate at which the height. So height is decreasing, so that's going to be negative 9, plus 2 pi times by the radius. Again, the radius was 19, and the rate at which the radius was changing was increasing at 3 inches per second, and then the height is going to be 9. So, punch that into a calculator. Looks like the key keeps it in terms of pi, so if we consider that, if we do 19 squared times by negative 9, we get negative 3249 pi, plus, then we're going to do 2 times 19 times by 3 times by 9, and that's going to be 1026 pi. So then if we add those, we get negative 2223 pi inches cubed for every second. Don't forget units, okay? Okay, one more. A man flies a kite at a height of 120 meters. The wind carries the kite horizontally away from him at a rate. So, got like this kite. Let's see. The man flies a kite at a height. So, here's the kite. The man. And the height is 120. I don't think it's referring to the diagonal height. Height of 120 meters. The wind carries the height horizontally. So the rate at which it's being carried away is 7 meters per second. So whenever I refer to a rate, I usually draw an arrow with it so I know that it's changing. So 7 meters per second. How fast is the distance between the man and the... Okay, so the distance between the man and the kite, that would be this one right here. So what is this rate changing at when the kite is 130? Okay, and then, oh man, the only reason why I don't like these problems is it's kind of hard to tell from the language. So, and the kite, when the kite is 130 meters away from him, so I think that's saying this is 130, I think. So this is 130, okay, this is, okay, so, so for variables, let's find x. So using Pythagorean theorem, we can say 120 squared plus x squared is equal to 130 squared. So 130 squared minus 120 squared is equal to 2500, and we take the square root of that and we get 50. So x is equal to 50. Okay. This is constant right here. So I have x squared plus y squared is equal to z squared. That's how we're going to relate all these variables together. But y squared is constant. So x squared plus 120 would be equal to z squared. So if I take the derivative, I get 2x dx dt equal to 2z dz dt. Don't really need the constants there, they'll cancel each other out. So x will be 50, dx dt is 7, z is 130, dz dt is what we're trying to find. So do some algebra. So 50 times 7, divide that by 130. Okay, I think we're good. This is equal to 2.7, and the units will be meters per second. That's how far, that's the rate at which the distance between him and the kite is changing at. So, okay, so that is a review. Hopefully it helps, and let me know if you have any questions.